Welcome. In this session, we will take a quick look at finding one-sided limits. The basic rules for limits also apply to one-sided limits. So they distribute over arithmetical operations as long as the result is defined. And it turns out we can do one more thing. When we simplify functions, it's enough to use rules which apply on only one side. This is especially useful when we have piecewise defined functions. So we look at examples of calculating one-sided limits with such functions. To be precise, if I have a function f of x and it equals g of x whenever x is close to a and a little bit bigger than a, then the limit from the right are equal. So we have such a situation in this example. We are finding the limit as x approaches 3 from the right of x minus the greatest integer function. Now remember, the limit rule started with constants and x, so they really apply only to algebraic functions. You can also extend it to logarithms and exponentials, as I mentioned before, but we cannot apply it to other types of functions, certainly not to the greatest integer function. So we need to somehow say that this limit is the limit of some algebraic function. The point is that if x is between 3 and 4, the greatest integer function is just 3. Because if I take a number of the form 3 point something, 3 is the biggest integer which is less than or equal to that number. So from 3 to 4, the greatest integer function is 3, so x minus the greatest integer function is x minus 3. And this is a polynomial, so I know how to find the limit. It's the value. So as x approaches 3, x minus 3 approaches 3 minus 3 or 0. Let's do one more limit, this time from the left. The same principle applies. We will do the limit of x minus the greatest integer function at x as x approaches negative 2 from the left. So I want to take a number which is a little bit less than negative 2. Remember that the greatest integer function is the largest integer less than or equal to the input. So if I take a number a little bit less than negative 2, so for example negative 2.001, negative 2 is a little bit bigger, so I have to go one down to negative 3, and that's the largest integer less than or equal to negative 2.001. Of course, if I take any number which is just a little bit less than negative 2, the same procedure still works, which means the greatest integer function will equal x minus negative 3 for any number between negative 3 and negative 2. So x minus the greatest integer function at x, at any such number, will be x minus negative 3 or x plus 3. And since that's a polynomial, the limit equals the value, which is negative 2 minus negative 3, or just 1. This is a basic illustration of how you calculate one-sided limits for non-algebraic functions. If on each side they can be expressed in terms of algebraic functions. We'll continue this with case-wise defined functions in the next session. Goodbye for now.